Today's lesson is 12.2, solving radical equations. Today we will be solving for x in equations that have square roots in them. So when solving for x, right, we generally do the opposite of order of operations because we're basically unwrapping the problem, right, usually adding to the opposite sides in order so that we can multiply or divide from the opposite side. So we can just solve for 1x, right, because 8x plus 3 equals something. Well, now we're going to have square root of something, and square roots are actually exponents. Right, we'll learn what that looks like in 12.3 specifically, but the opposite of a square root is a square. Right? So what we're going to do is we're going to be squaring both sides to unwrap the square root and solve for what's inside. For example, solving for x, we've got the square root of x plus 5 is 4. Now, a way to think about this is, besides, squaring the opposite is, well, what square root of what number is 4, right? Well, square root of 16 equals 4. So that means this x plus 5 has to equal 16. Well, mathematically, what does that look like? Well, that looks like squaring both sides. So doing square to both sides like this would cancel that, right? Because then we're basically saying, well, what's on the inside here? So these will cancel, and then we'll get x plus 5. I didn't mean to cancel the x, but x plus 5 equals this 4 squared, which is 16. And then we're just solving from there, right? Opposite opposite of adding or subtracting, right? So we're adding here, so opposite is subtract 5 from both sides, and then 16 minus 5 is 11, so x is 11. Now, I will say this is not exactly PEMDAS because we're looking at exponents first. So in this case, there was nothing to add or subtract away from the exponent, so we squared to get rid of the exponent, and then we restarted PEMDAS because inside, these are technically inside of parentheses, right? Because it's not the square root of x. It's a square root of x plus 5, all that first, right? So in this case, the second problem, we have to deal with the plus 3 first. Because if we wrote PEMDAS out here, as so, right, and just kind of do it as a checklist here, right? At this point, we're working up, right? Can we add or subtract away? Yes, we can. We got to deal with this plus 3. What are we going to do? Opposite of plus 3 is minus 3. So subtract 3 from each side. Getting square root of x plus 7 equals 4 minus 3, which is 1. Oh, here we go. So we didn't have any multiplying or dividing to do, right? And just a note, what would that look like if we did? That would be like this, 5 in front. But we don't have any of that here, so we'll just undo that. So we skipped this step because it wasn't there, and then we dealt with that fact that a square root's an exponent, and we need to square it, right? If this x plus 7 equals 1 under a square root, right? Well, that would mean that when we square both sides, this value has to add equal 1 because the square root of 1 is 1, right? So x plus 7, square root of x plus 7 equals 1 gives us x plus 7 equals 1. We squared both sides, just to note, 1 times 1 is 1. So this doesn't look like it changed, but it was squared. Subtract 7 from both sides, and we get x is minus 6. You can plug it in to make sure it works. Minus 6 plus 7 is 7 minus 6 is 1. Square root of 1 is 1. 1 plus 3 is 4. And we're done. Next couple. The square root of 8x plus 1 plus 2 equals 11. So again, kind of following PEMDAS. I'll write it out one more time here. And we've got plus 2 first on the outside. So we need to subtract 2 from both sides. 11 minus 2 is 9. And now I have the square root of 8x plus 1 equals 9. Well, that means, well, what square root equals 9? Well, square root of 81 equals 9. So 8x plus 1 needs to equal that 81. Again, squaring both sides. Now, if it helps you to think about it that way, that is the kind of the words, right? What the square root of what number equals 9? Well, that's 81. So this needs to equal 81. If you understand the squaring is opposite, you can just do the square. 9 squared is 81, and we're ready to compute. Okay. The only reason I mention this is there are some people that struggle and would maybe say, oh, 9 squared, that's 18. Now, remember, it's 9 times 9 is what that square means. Moving on, 8x plus 1 is 81. Subtract 1 from each side. And notice, once we unburied this, right? We went up, we added, subtracted, we skipped this step, it wasn't there, we did the exponent, and now because there was technically extra stuff inside, that caused us to go all the way back down, and then we're adding, subtracting again to solve for x, right? Because we had 8x plus 1, and we want just x. So it is okay that we did adding, subtracting twice. We couldn't have done it before getting rid of the square root. And then we multiply, divide by 8 on both sides. 8 times what is 80? We get 8 times 10, so x is 10. That's our final answer. Plug it in to double check. We won't do this every time, but you can, and very recommended to do so on, say, a test or quiz. 8 times 10 is 80. 80 plus 1 is 81. What times what is 81? 9. So the square root of 81 is 9. 9 plus 2 is 11. Check. It worked. Next one. Square root of 7x minus 6 is 8. Squaring both sides, we're going to get 7x minus 6 is 64. Plus 6 to both sides. 7x is 70. 6 plus 64 is 70. 7 times what is 70? X is 10 again. 70 minus 6 is 64. Square root of 64 is 8. It checks out. Moving on, what do you do if they're both square roots? Right? The only way these are equal is if the number insides are both equal. Right? You can't have the square root of 25 equal the square root of 30. They would both need to be the square root of 25 to be equal. So all we're doing is we're going to square both sides, and basically what's going to happen is the insides are equal. So 3x plus 7 equals 5x minus 3. And then we're solving. As a reminder on how to solve these, we're moving the smallest amount of x so that we don't have to deal with a negative number of x. And so we're going to subtract 3x from both sides. And because we moved our x's this way, we're moving our numbers the other way. So the opposite of minus 3 is plus 3 to both sides. 7 plus 3 is 10. 5 minus 3 is 2. Divide by 2 on both sides, and we're going to get x is 5. Plug it back in. 3 times 5. 15 plus 7 is 22. 5 times 5, 25. Minus 3 is also 22, so they match. Next one, square root of 7x plus 1 equals the square root of 9x minus 9. Squaring both sides, so 7x plus 1 equals 9x minus 9. Moving the 7x first, minus 7x to both sides, adding 9 to both sides, and again we get 2x is 10, and x is 5. Really like the numbers 5 and 10 this lesson. Next slide. You get the pattern, try these on your own, and unpause once you have it. And so the steps are squaring both sides, 7x minus 5 equals 3x plus 11, moving the 3x first, minus, minus, and we're plussing 5 to both sides. We're going to get 4x is 16. Let's divide by 4 to get x is 4. 28 minus 5 equals 12 plus 11. They both equal 23. Same idea over here, squaring both sides. 9x minus 17 equals 4x plus 18. Subtracting the 4x, and then we're going to move the 17. 5x is 35. It gives us x equals 7. That wraps up today's lesson. Feel free to email if you have any questions, comments, or concerns.